Hello, my nerdy Nawg-Dawgs. This is your week 7 mini lesson for Tuesday. And we have been talking about squares and rectangles and solving for perimeter and area and missing measurements and how to solve for that. Well, this just adds to the puzzle, and the puzzle that is the fun part of solving for area. And it's working with composite shapes. So in your live session on Monday, you did get a quick introduction to this. And today you will be doing it on your own. So if we're looking at composite shapes, what are composite shapes? Well, they are shapes that are not as easily to solve for as a square and a rectangle, because you can't use the basic formula for area or perimeter without first dividing and conquering. Keep that in mind. Okay, so here we go. In this case, we have an L shape. An L shape, I can't use the standard formula for area to solve for, and that's what I'm being asked for. So my first question, my nerdy Nawg-Dawgs, is, what is the formula for area? We must hang on to this. If we can remember the formulas, I promise you, you can solve for anything. So the formula for area, my friends, is length times width. Remember that, remember that, remember that. Hang on to it. Okay, in the live session, several of you were able to identify and tell me that the easiest way to solve for a composite shape would be to break it up into squares and rectangles, because we already know how to solve for those. So that is exactly what we could do to this L shape. I could take this top portion and make it a separate rectangle. Now, here it's about to get even easier, because if we notice, this yellow rectangle already has its length and width in place. It tells us that the length is 6 and it tells us that the width is 3. Therefore, I can plug that directly into my formula and say 6 as the length times 3 as the width. And I know that the area for this yellow rectangle would be 18 miles squared. Okay, so let's see if I can get that written down legibly to where you can read it. There we go. Can you read that a little bit? 18 miles square is the total for the yellow rectangle. However, we still have to solve for the bottom portion, because that is part of the original shape. Okay, so now let's solve for this lower rectangle. We'll call this the green guy. And our green guy does not have any values in place or measurements for its side lengths, because it is not 8 miles in length. That 8 miles was to register the full length of the L shape. What I do see right off the bat, though, is, and let's see if I can choose another handy dandy color, I see that this portion at 3 miles, I can take what I know about a rectangle. I know that it has 2 sides that are parallel. Okay, or the parallel sides are the same measurement. Let's reword that. So I know if this measurement is 3 miles, then this side is also 3 miles. So then what I can surmise is that the total length, which would be 8 miles, I can take away this 3, and I know what remains then is 5 miles. Okay, is this starting to measure up? So if that is 5 miles, now what's missing or what's in question is this measurement there. And what I see directly opposite is this length, and the full length is 6, and that's too long. But if you notice, this portion right here is 3, so that would be the missing measurement down here. So I can say 6 minus the 3 gives me 3 as that portion of the measurement. Now, if I go back to my formula for area, to solve for this green rectangle, it would be 3 times 5, which we know gives us 15 miles squared. Okay, We're not quite done yet. My last step would be to add the green rectangle together with the yellow rectangle. And that would be then the 18 miles squared plus 15 miles squared. If I do my mental math, I know that 15 plus 15 is 30. That's easy math. And then I just have the 3 from this ones column to add in. So that would give me 33 miles squared. Don't forget this 2 as the exponent. That is what tells us that it's two-dimensional, right? It's a flat surface, and it would take up 33 miles squared in a great big rectangle on the ground, I guess. I mean, we're talking about miles here, right? Okay, so hopefully this is starting to make more sense. I have one more to do together, and then I have kind of a challenge one that will show up in your work this week. Alrighty, so let's take a look at the next shape. Oh, this is kind of a funky shape. It's got a puny, a little tiny rectangle that doesn't really fit in here. So what we automatically want to do is look for the shapes that we can solve for. And right off the bat, I see this larger rectangle here that would make it real easy to solve for this green rectangle and what's inside of it. Okay, I'm going to separate out that weird skinny puny rectangle, and we will solve for that separately. Now, right off the bat, I can refer to my formula for area, length times width, and I see that I have those measurements for the green rectangle. I have 12 as my length, and that's right there, and I have 4 as my width. Okay, so if I'm doing my mental math, instead of 12 times 4, I can think of that as 10 times 4, and then I know that's 40, and I still have my ones to do. My 4 times 2 is 8, and therefore I know that the green rectangle is 48 feet squared. Okay, very important to include that exponent. I'm not done though, right? And you guys know that. There's still this skinny, weird rectangle to solve for right here. I don't know how that would hold that shape up. So what I do know is the full length across is 12. That doesn't necessarily help me unless I see that this portion, let's change my color, make it a blue. See that this portion here is 6, and this portion here is 5. And so that would be the same as up here. So what's missing is this little yellow top portion there. And so if I compare it to the other side of 12, 12 minus 5 minus 6 gives me 11, which means that this orange section here can only have the value of 1 foot. Okay, so now I've got one of my measurements. I'm going to call that my width. My width is 1 foot. Okay, but I still need to find my length. And if I notice over here to the right, this is showing me that it is 6 feet from that point down to the bottom. So then I know that my length is 6. So my formula for area becomes 1 times 6. Easy enough to solve for. That would be 6 feet squared, because I can imagine that there's the 6 little cubic units here, and that's 1 foot by 1 foot. So 1 foot by 1 foot squared. So the total square footage for the yellow rectangle is 6 square feet. And then I would need to add that to the green rectangle, which was 48 feet squared, or squared feet, which would give me then 54 square feet for the total of this weird T shape. Okay. Almost done, nerdy Nawg-Dawgs. Last little preview to go. Let's clear this board and take a look. Okay. In this case, the reason I wanted to do this one with you guys on our mini lesson is it is not a regular shape, and there's much to solve for here. And then on top of all that, it's asking us for perimeter and area. But that's okay, my nerdy Nawg-Dawgs. If you know the formula, you can solve it, and I know that you guys know this stuff. So right off the bat, what I suggest doing is identifying all the missing measurements, okay? And there's a few of them. I see that this is missing, that's missing a measurement, that's missing a measurement, we're missing a measurement there. Now this over on this side, I can assume that it is the same measurement as this. So I can go ahead and write in 14 there. Do you guys agree with that? Gosh, I hope so. Okay. Now what I do see is that this tells me that portion is 3 feet. And when I look up here, this is equivalent. So that's also 3 feet. Then I see that this length is 4 feet, which matches here. So I can put in a 4 foot there. I see that this measurement is matching to that 3 feet. So I can add another 3 there. And then I see that this missing measurement matches with that measurement and is a 4. Okay. What is my formula for perimeter, my friends? Well, my formula for perimeter is P equals side plus side plus side plus side. So in this case, I just have to add up all the sides. And I'm not going to do a long, weary addition problem, so we're going to do some mental math, and I know you guys got this. 14 plus 14. You take numbers that are reasonable or that are similar, and you know that you can use in your head right away. And so I know that 15 plus 15 equals 30, and this is 2 less. So I know that my 14 plus 14 would give me 28, right? Now I'm going to go with all my even numbers because that's just easier to add up in your head. Some of you might want to add up and work with bigger totals, but I'm going to mark them out as we go just to be nice and even. So we had 28. We're going to add another 4. 28 plus 4 gives me 32. Add a 4 here. That gives me 36. Add 4 more. That brings me up to 40. Here's my last 4. That gives me 44. Okay, and then I have my 3s. So 44 plus 3 gives me 47, plus 3 more gives me 50, plus 3 more gives me 53, plus 3 more gives me 56. And I know that my perimeter is 56 feet. Now, that's not squared. That would be Miss Nagdev walking around this whole shape with a piece of string and cutting it off when I got to the end, and then pulling my string out and measuring it, it would equal 56 feet. Okay, perimeter. Last thing to solve for now is area. Now here's the thing. We can use our formula if we can cut this shape into squares or rectangles or things that are easy to use the formula on. In this case, I see right off the bat, here's a nice little square. I'm going to color that guy in. Here's a nice little square. I'm going to color that guy in. And then what I can do is I can take this large rectangle here and solve for that separately. Okay, so now we have our orange rectangles or square in one case, and we have our great big yellow one. Okay, so what is my formula for area? Length times width. Well, I've got a couple of my measurements right here. In this first orange square, I see 3 times 3. That gives me a total of 9. Now, again, that's squared feet squared or squared feet. Okay, we have solved for 1, and that was actually a perfect square, right? 3 by 3. Now I've got this one over here, orange square. It's 4 by 3, so it is a rectangle. And for my formula for area, it would just be 4 times 3, which gives me 12 squared feet. Okay, so all I have left is the yellow portion. Now, I can see right down here 1 length. That would be the 4 plus 4 plus 3, so 8, 9, 10, 11. 11 feet is the total length of one side. And this over here, I know it's not 14 any longer because 14 was the full length. So what do? I do 14 minus this portion here, which was 3. 14 minus 3 means that this is 11. Guess what? This is a square too. So to solve for the yellow square, it would be 11 times 11, which gives me 121 square feet. So now I have to take all of my totals and add them up together. 121 plus 12 plus 9. You nerdy Nawg-Dawgs doing that in your head? 121 plus 12 plus 9, 10, 12, 3, 4. Okay. So this entire weird shape measures out to be 242 feet squared. Oh, my nerdy Nawg-Dawgs, I think our work here is done. So if you find you have any questions, send me a chat. I can add you into a small group either on Thursday to review old material or Friday to review composite shapes, okay? And I guess that's it, nerdy Nawg-Dawgs. Reach out if you need some help. Otherwise, I will be talking to you soon. Bye, guys.